Imagine you could jump high enough to dunk a basketball or lift a car with ease. Sounds like a superhero movie, right? Well, it might not be as far-fetched as you think. Welcome to the fascinating world of gravity, the unseen force that keeps our feet firmly planted on the ground and the planets orbiting around the sun. It's a fundamental aspect of our universe, shaping everything from the smallest particle to the largest galaxy. But what if we could manipulate gravity? What if we could shield it, reducing its pull, or amplify it, increasing its force? It's a mind-bending concept, straight out of science fiction. Yet, as we delve deeper into the realm of theoretical physics, the line between fiction and reality starts to blur. Understanding gravity is essential to understanding our universe. It's the glue that holds everything together. Without it, there would be no planets, no stars, no galaxies. It's the force that shapes the cosmos. And yet it's also the force that makes a raindrop fall to the ground. But gravity is more than just a force. It's a curvature in the fabric of space-time caused by mass and energy. Imagine a trampoline with a bowling ball in the center. The ball creates a dip, a curvature. Now, if we roll a marble across the trampoline, it will move towards the bowling ball. Not because of a mysterious force, but because the ball is following the curve of the trampoline. That's how gravity works. Now, let's take this concept a step further. What if we could manipulate this curvature? What if we could flatten it, reducing the pull of gravity, or steepen it, increasing the force? This is the intriguing concept of shielding or amplifying gravity. It's a new frontier, a potential revolution in our understanding of the universe. But before we dive into this fascinating possibility, let's get a handle on how gravity works in the first place. Gravity. It's the force that keeps us grounded, literally. The force that makes the apple fall from the tree, the force that keeps our feet firmly planted on the earth, the force that makes the moon orbit around us and us around the sun. But what is gravity really? At its most basic, gravity is a force of attraction. Every object in the universe, no matter how small or large, exerts a gravitational pull on every other object. This means that you and I, and even the smallest speck of dust, are all pulling on each other gravitationally. However, the strength of this pull depends on two key factors: mass and distance. The first factor, mass, is pretty straightforward. The more mass an object has, the stronger its gravitational pull. That's why we feel much heavier on Earth than we would on the moon, which is only about 1/6 the mass of the Earth. The second factor, distance, is a bit more nuanced. The gravitational pull between two objects decreases rapidly the farther apart they are. So while we are indeed pulling on each other gravitationally, the effect is so tiny as to be virtually unnoticeable because we're relatively small and not very close together. But gravity isn't just about objects pulling on each other. According to Einstein's theory of general relativity, gravity is the result of the way mass warps the fabric of space-time. Imagine a bowling ball sitting on a trampoline. The ball creates a dip in the trampoline surface. That's what mass does to space-time. It creates a sort of well that other objects fall into, creating what we experience as gravity. So in essence, gravity is a dance of mass and distance playing out on the stage of the universe, choreographed by the curvature of space-time itself. So, now that we've got a grip on gravity, let's venture into the realm of the theoretical. In the world of theoretical physics, things get a little weird. Indeed, the peculiarities of this realm take us beyond our everyday experiences, and into a world where the impossible seems plausible. One such peculiarity is the concept of manipulating gravity. Now, you might ask, how on earth would that work? Or rather, how off Earth, perhaps? The key lies in a hypothetical particle known as a graviton. Gravitons, if they exist, are thought to be the mediators of gravity. Like photons carry electromagnetic force, gravitons would carry gravitational force. Imagine them as tiny invisible couriers, racing around the universe, delivering the force of gravity between objects. But here's where it gets even more intriguing. If we can somehow interact with these gravitons, we might be able to influence how they deliver this force. We might be able to shield gravity, reducing its effect, or amplify it, making it stronger. This is the tantalizing possibility that theoretical physics presents us with. It's important to note, however, that this is purely conjecture. Despite our best efforts, we have not yet detected a graviton or developed a surefire way to manipulate gravity. The world of quantum gravity, where gravitons reside, remains largely uncharted. It's a challenging landscape, fraught with mathematical complexities and philosophical conundrums. But don't let the uncertainties deter you. Theoretical physics is a hotbed of innovation and discovery. It's a place where daring ideas are born, where boundaries are pushed, and where our understanding of the universe is constantly challenged and expanded. So, while the idea of shielding or amplifying gravity might seem like science fiction today, who knows what the future holds? After all, once upon a time, people thought the Earth was flat and that the sun revolved around us. As we've learned, the universe has a knack for surprising us. While this is purely theoretical, it's these kinds of ideas that often lead to big breakthroughs. So let's keep pondering, questioning, and exploring the fascinating universe we inhabit. Who knows? One day we might just crack the code of gravity. So are scientists actually trying to shield or amplify gravity? Well, the answer is kind of. At the forefront of this exploration is the field of quantum physics. Here, scientists are in the early stages of trying to understand the elusive graviton, a hypothetical particle that could be responsible for gravity. If gravitons exist and can be manipulated, we could theoretically shield or amplify gravity. While we're still far from having a graviton in a lab, the research into these particles is ongoing and fascinating. Similarly, we have the Large Hadron Collider, the world's most powerful particle accelerator. While its primary function isn't to manipulate gravity, some scientists hope that its high-energy particle collisions might give us a glimpse into the quantum nature of gravity, possibly supporting the existence of gravitons. On a slightly different note, let's talk about superconductors. These materials, when cooled to incredibly low temperatures, display a strange effect called the Meissner effect, where they expel magnetic fields. Some experiments suggest that they might also affect gravitational fields. While these experiments are controversial and far from conclusive, they do represent a fascinating area of ongoing research. Then there's the concept of metamaterials, engineered materials with properties not found in nature. Some theoretical physicists propose that certain metamaterials could bend space-time, effectively shielding gravity. While this is purely theoretical and we don't yet have the technology to create such materials, it's a tantalizing idea that's spurring on new research. Finally, let's mention NASA's Breakthrough Propulsion Physics project, which ended in 2002. This project explored various exotic technologies for space travel, including gravity manipulation. Although the project didn't yield immediate results, it laid the groundwork for future research in the field. These experiments may be in their infancy, but they represent the first steps towards potentially manipulating gravity. From quantum physics to metamaterials, there's a lot to unpack and understand. So while we're not ready to shield or amplify gravity just yet, who knows what the future holds? After all, science is all about pushing boundaries and venturing into the unknown. Imagine a world where gravity could be controlled. What would that look like? In the realm of space exploration, the ability to manipulate gravity could propel us into a new era. Spacecraft could be equipped with gravity shields, reducing the gravitational pull of planets and making interstellar travel more feasible. The energy required to leave Earth's atmosphere could be drastically reduced, opening up endless possibilities for space colonization and exploration. Now let's bring it back closer to home. Imagine the implications for energy generation. We could harness the power of gravity itself. For instance, using gravity amplification, we could create high-gravity environments to drive turbines and generate electricity, potentially revolutionizing our energy sector. What about our day-to-day lives? Picture lifting heavy objects with ease thanks to gravity shielding technology. Construction work could be safer and more efficient, and we could design buildings in ways we never thought possible. But it's not just about the physical world. The impact on our understanding of the universe would be profound. If we could shield or amplify gravity, we could test theories in ways that are currently beyond our reach. We could create laboratories with different gravitational fields, allowing us to experiment and observe phenomena under unique conditions. And then there's the potential impact on medicine. In a zero-gravity environment, certain medical procedures could be performed more easily. For example, surgeries involving the cardiovascular system could be done without the constant pull of gravity on the blood, but it's not all rosy. There's the potential for misuse. An amplified gravity weapon, for instance, could cause catastrophic damage. And what about the environmental impact? The effects of manipulating gravity on a large scale are unknown and could have unforeseen consequences. The possibilities are mind-boggling, but they also come with some serious challenges. But isn't that the nature of scientific discovery? It's a delicate dance between the thrill of the unknown and the caution required to navigate uncharted territory. It's a journey that we, as a curious species, are destined to undertake. Manipulating gravity isn't just a scientific challenge, it's also an ethical one. As we delve into the realm of gravity manipulation, we're not just wrestling with the laws of physics, we're also grappling with profound ethical questions. What happens if we gain the power to shield or amplify gravity? Who gets to control such a potent force? And what could be the potential consequences? Imagine for a moment that we develop a technology that can manipulate gravity. Suddenly, we have the ability to make things lighter or heavier at will. This could revolutionize everything from construction to transportation, making all sorts of previously impossible feats achievable. But it could also disrupt our delicate ecological balance, as organisms and ecosystems adapted to specific gravitational conditions could be thrown into chaos. Then, there's the issue of societal impact. Could gravity manipulation become a tool for oppression, a weapon in the hands of the powerful? Or could it be a force for good, leveling the playing field and creating new opportunities for all? These are not just hypothetical questions. History teaches us that technology is never neutral. It reflects the values and power structures of the society that creates and uses it. The balance of power, too, is a significant concern. If a single entity, be it a nation or a corporation, gains exclusive control over gravity manipulation, it could wield unprecedented influence. This could lead to a new arms race, with nations scrambling to develop their own gravity manipulation technologies. And let's not forget about the potential for accidents. What if a gravity shield fails, or an amplification device goes haywire? The results could be catastrophic, with potentially global ramifications. Finally, there's the question of our moral responsibility to the universe. If we have the power to manipulate one of the fundamental forces of nature, do we have the right to do so? And if we do, how do we ensure we use this power wisely and for the benefit of all? As with any powerful technology, the key lies in responsible and ethical use. Today, we've taken a deep dive into the fascinating world of gravity. We've journeyed from the basics of how gravity shapes our universe to the theoretical possibilities that dare to challenge our understanding. We've peeked into current experiments and technologies that are pushing the boundaries of gravity manipulation, even if they're just in their infancy. We've imagined the potential applications of shielding or amplifying gravity that could revolutionize space travel, energy generation, and even our day-to-day life. We've also pondered the challenges and ethical considerations that accompany this bold idea, acknowledging that the manipulation of gravity, if possible, could have far-reaching impacts on the environment, society, and the balance of power. It's a reminder of the gravity of the situation, pun intended. So next time you feel the pull of gravity, remember, it's not just a force, it's a doorway to countless possibilities. Thank you for joining us on this journey through the world of gravity. If this sparked your curiosity and you're eager to unravel more mysteries of the universe, hit that subscribe button. Let's continue this exploration together. And if you have thoughts or theories on gravity manipulation, we'd love to hear them. Drop them in the comments section below. Remember, science is a journey, and we're glad to have you on board. Until next time, keep wondering, keep exploring, and keep questioning.